All right. So, hopefully this is recording correctly. Cancel. So for this, just an initial thing when you see it, like my first thought is to let the denominator be u. Okay. I'm also thinking about conjugates, like multiplying by 5 plus root x, or 5 minus root x to see if that squares out one of them, makes it look a little bit nicer. But I like doing this because rather than changing it, we can just try to get the du that we need. So we'll let u be the denominator, and du is that negative 1 over 2 root x dx, which we don't have in this integral. So what we're going to do is we're going to add it in. So I'm just going to multiply in here by a 2 root x negative on the bottom here. And that's going to give me the du that I want right here. So all of this junk here is going to become du. But I'm only allowed to do that if I also multiply it by the top. So you can see that if I were to simplify this back down, it would go back to the original integral that I came from. However, we're not going to do that. We're going to let this become the integral. This denominator becomes u. We have du back here. Again, that was like what's all the circle stuff. But now up top we still have, I'm leaving it in blue, can we separate it out? This 5 plus root x is here still because we haven't done anything with that, right? That's this. And then you also have this thing kind of chilling. And normally that'd be a problem. You're like, oh, I don't like this. But what we're going to do is I'm going to, you can distribute this in first, or I'm going to come down here. It doesn't matter. It's going to simplify the same way. But if u equals 5 minus root x, anytime you do a u sub and you have an extra x left over, like here we have x here, another x here, then something you can try is to solve for x in your substitution. So if we solve for root x here, we get that root x is 5 minus u. So because root x equals that, I'm just going to put in a 5 minus u here and a 5 minus u here for those root x's. Okay. And in hindsight, it actually looks like it's going to be a little bit easier if I distribute this first rather than do that, because I don't want to have 5 minus u's floating around there. So I'm going to distribute this here and distribute this here first. We're still going to do the same substitution. I'm just going to make it look a little bit nicer. So this is really negative 10 root x minus 2x all over u is what that is if you distribute that negative 2 root x into there, right? Because negative 10 root x minus 2 root x makes an x. Okay. So now I'm going to sub in that root x is this. So this becomes the integral of negative 10, and root x is just 5 minus u. Then we have minus 2, and now I have an x there. So if root x is 5 minus u, then x is just 5 minus u squared, which is really just, what's this, 10u plus u squared. So that x that's right here is really 5 minus u squared, which is this thing here. So that's what that's going to become. So this becomes, I forget already what it was, 25 minus 10u plus u squared. And that's all over u, and there's a du at the end here. So just to recap here, I let u be the denominator. I didn't have the du that I wanted, so I just forced it to be in there while kind of canceling it out at the same time. So I put negative 2 root x on the bottom, negative 2 root x on the top, and that simplified down, overdid this thing. And because I had those extra root x's left over, I just solved for it right here so that I could sub them out into my integral. Okay. So now we're here, and this looks like a mess, but it's actually going to end up multiplying out and being relatively simple now. So this is negative 50 plus 10u, if you distribute this into there, right? Negative 50, I don't want to mess this up, plus 10u, minus 50 plus 20u, right? Minus 50 plus 20u minus 2u squared. And that's all over u with a du at the end. And we can only combine a couple things here. So this is really just, I'm going to be a little bit lazy, but that's negative 100, right? That's negative 50 and negative 50. And then we have 10u and 20u make really 30u. And then 2u squared divided by u becomes, oh wait, we'll leave it the way it is. Sorry. So that's what the numerator becomes when you combine all those terms. Right? Negative 100, 30u, that's right, minus 2u squared. And we're dividing all that by a u. So this integral really just becomes negative 100 plus 30 minus 2u. That's if you're dividing the u, like the u, let me switch colors up again. The u divides here, here, and here, and I messed up. It's really negative 100 u to negative 1. There we go. Okay, so again, that's negative 100 divided by u, 30u divided by u, and negative 2u squared divided by u. All right, so anyway, when you actually get to integrate this now, it just becomes negative 100 ln of u plus 30u minus u squared plus c. And that's just, again, integral this, integral this, integral this. And because u was something, what did we say it was? 5 minus root x or something? U was 5 minus root x. We're just going to plug that in. So this becomes negative 100 ln of 5 minus root x plus 30 times u, which was 5 minus root x, minus u squared. So you can either square that out or just leave it like this, plus c. But if you do expand it out, like I'll show you too. Sometimes if you drop this into like an online calculator, they're not going to have that answer. They're going to expand it out, and they're going to get 150 here, 30 root x here. That's just distributing this piece here. And then this is going to become minus 25 minus 10 root x plus x if you square that out. Right? 25, 5 and 2 is 10, right? Root x, okay, good. And then they would combine some terms here. They'd have negative ln 5 minus root x. You can see here we have a plus 150, and then we're going to have a minus 25 here. So there's really a plus 125. We also have a minus 30 root x, but then we're also going to have a plus 10 root x. So that's going to be minus 20 root x there, right? Negative 30 plus 10, yep, and then minus x plus c. And so any one of these is a totally fine answer here. Like this one is what I would probably stop at, to be honest. If you expand it out, that's fine. But again, if you drop this into like Wolfram Alpha or something, they're probably not going to have this 125 in there, because the plus c means we're adding some constant at the end, and the plus 125 could just be part of that. So you might also see, if you check an answer key, they might also have an answer that looks like this. And again, they're just putting the 125 since it's just a constant with that constant term back there. So any one of those is going to be an okay answer. But if you're checking an answer key, you might see any one of these. All right. Hope that helps.